If you have a history of psychiatric illness, you're more likely to have a side effect to a commonly prescribed anti-seizure medication. And if you have a history of psychiatric illness, you're more likely to have medically refractory seizures. And that means that you've got fewer and fewer medicines to work with, and there's a higher and higher likelihood of needing to have a surgical treatment.
Fellow Homo sapiens, welcome back to Epilepsy Sparks Insights. So it is amazing if a person with a refractory epilepsy can get hold of an epileptologist. But then it's even more impressive when, if you need one, you can find an epileptologist who works on and researches the triad of epilepsy, intellectual disability, and autism. And I say that because these diagnoses all too often do come hand in hand, and often needed as a result is a clinician who understands all three. That is why I am delighted to, this week, bring to you the exciting clinician scientist, epileptologist, Vaishnav Krishnan, from the Laboratory of Epilepsy and Emotional Behaviour at the Bayer College of Medicine. And he ticks all of the aforementioned boxes of knowledge.
My name is Vaishnav Krishnan. I'm an epileptologist for adults at the Baylor College of Medicine here in Houston, Texas, in the Texas Medical Center. As a clinician and as a neuroscientist, I'm interested in studying more generally the problem of mental health disorders in patients with epilepsy. And so to get at that, I run a small lab that uses digital technologies to study behavior in mouse models of epilepsy and mouse models of epilepsy treatment. And simultaneously, we're studying wearable technologies in humans with epilepsy to ask, how can we align those measurements across species and do a better job of coming up with better treatments that are holistic and address both not just the seizures, but also other neuropsychiatric comorbidities that come with epilepsy.
And so I think, well, many of us know, many of us don't know that that humans and rodents are so similar in many ways, especially when it comes to the epilepsies, correct?
Weighted question, how much time do I have? It's true that both species have the circuitry to display seizures. Unlike other neurologic diseases, we can induce seizures in both rodents and humans. We share the same neurochemistry, share the same neurotransmitters. Obviously, there's differences in lifespan, differences in behavioral repertoires. But yes, in general, rodents are a good model to study both the seizures and the non-seizure aspects of epilepsy.
Keeping in conversation then seizures, epileptic seizures, autism and intellectual disability, which are often like a bit of a threesome, to put it politely. Can you tell us about the correlation between all three and what you've discovered in your research about those, please?
So yes, I like the way you put it. I like to call it a triad: seizures, intellectual disability, and autism. There's been a lot of epidemiological work to look at the link between these three symptoms. It turns out that epilepsy increases the risk for autism, autism increases the risk for epilepsy, and so it doesn't really matter which one comes first, they both tend to go together, and the link that seems to connect them is intellectual disability, which is a broad term to basically denote someone that has difficulty learning and has difficulty functioning independently. So what does that mean at a very practical level? It means that many genes that we think of as epilepsy genes in humans may not cause seizures, but may simply cause autism and intellectual disability. But what it also means is that in mouse models of epilepsy, we may be able to find evidence of autistic behaviors and changes in intellectual function. At the end of the day, you have a single underlying lesion problem. What you're measuring are the symptoms of that lesion.
And you say lesion, so is it that type of epilepsy that you tend to focus on, or a bit of genetics as well, which, well, they can come hand in hand, obviously?
Yeah, great question. So the triad, autism, intellectual disability, and epilepsy, often is manifested with early onset seizures that begin in childhood. And if you ask more generally, what are the causes of childhood onset epilepsy, they can be broadly divided into genetic causes and also structural causes, like, for example, changes in brain shape, malformations, as well as other environmental causes, such as, for example, perinatal hypoxia, basically not enough oxygen at the time of birth. Of those three, the ones that are easiest to recapitulate in the lab are the genetic causes, right? Thanks to the technologies that we have today. Any genetic mutation in a human subject that's associated with epilepsy can be recapitulated in a mouse. And you can ask a simple question, does that mouse, in comparison to its genetically normal counterparts, have a higher risk of displaying seizures or intellectual disability or autistic features? So yes, I would say that the mouse models that have had the most success in epilepsy have been genetic ones. But there's tricky stuff involved, right? Many of the mice that are designed to recapitulate those mutations actually don't have seizures. So what do you do then? And what does that mean? So these are some issues that we deal with.
I've heard about sometimes people having, on paper, the same genetic epilepsy, but they will have different traits. So some ones I've come across, there might be one person who doesn't have any degree of intellectual disability. In fact, one person I met, he was a scientist himself, but he had the same genetic disease or genetic epilepsy as the multiple relatively young children that I saw around me. It's totally varied, correct?
Very, very varied. We call that phenotypic heterogeneity. And that boils down to several different factors. Obviously, the genetic background is hugely important. That's why the same mutation in one line of mice may not be seizure prone, but in another line of mice, another genetic background may be seizure prone. There's also environmental differences that come about from sociodemographic factors, environmental exposures, that all play a role in deciding not just whether a patient will have seizures, but also when their first seizure will be. And that's what makes human research messy. And that's what drives researchers to go towards simple animal models to ask very basic questions.
At least first of all, I guess, and hopefully...
Right, the challenge is how do you bring those insights back to the humans? And these are the million-dollar questions that we're working on right now.
And I guess that's why the roles plural that you hold are of benefit, right? We were talking about this before. So you're an epileptologist, you work with patients, but you're also in the lab. And we were also saying how, or I think you implied that perhaps sometimes the way that you look at things, having patient and family insight, can be a bit different to people who don't have exposure to families.
Being able to connect with patients and families and learning their experiences and prescribing the poisons that we have to treat these seizures and recognizing the successes and failures is, I think, indispensable for me personally as a clinician scientist. But at the same time, I think transforming those big picture clinical questions into animal experiments is difficult, and many labs do it in different ways. And so, yes, I think I have a unique perspective from both angles. But as I said, the challenge is always how best to translate across these fields.
If you're enjoying this episode, and if you would like to help us spread awareness and understanding of the epilepsies around the world, please do consider liking the episode and subscribing to the channel, because it really does mean a lot. Thank you in advance.
Do you ever speak to your patients and consider, no doubt, in your research, how sometimes adjustments in lifestyle can impact patients' quality of life, whether we're looking at seizure control or whether we're looking at psychiatric issues, and that would include in many people with autism, like the stress from such and such, you know. Sometimes you can make changes in your lifestyle, right?
Yes. I think that what I tell my patients is that there are some things that I don't have a prescription for. Right? There are things that you can do in your life to manage your stress better. Get a dog, walk the dog, yoga, meditation, deep breathing. Go join a cooking class, be a part of a church group, do something spiritual as a part of a team. And that's hard because the depression and anxiety that comes with their epilepsy, or the changes in social drive that come with the autism in their epilepsy can preclude some of those very same activities. Even something as simple as engaging in therapy for a short period of time, just a few sessions, is very difficult sometimes for patients to wrap their heads around. And it often, they accuse me of calling them crazy, which is not the case. I never said that word. It's just that, these are neighboring signs that come with seizure risk. So I only have so many medicines that I have available. There are things that are better left treated without medicines. So diet is one of them. Obviously, you've probably had sessions on the ketogenic diet and the modified Atkins diet. Sleep and sleep hygiene is obviously crucial. And then there's this other stuff that's difficult to measure that is probably a key part of the resilience that we see in some patients that are seemingly unaffected by depression and absent in those that are affected.
I think personal relationships often can't be changed overnight. Or if you're in a remote area, how can you get closer to a city? Well, often you don't have a job or you don't have the energy to do it. And there are so many factors, right?
Definitely. I have patients that say, my seizures only ever come when my family visits me during Thanksgiving or Christmas. And I tell them once again, I don't have a medicine for that. I don't have a treatment for the psychosocial stressors, ongoing stressors that can promote seizures or other stress issues at the time that you see your family.
What would you say if you could predict, sort of the next 2, 5, even 10 years of your research? And we want people to, because a huge thing here is to manage people's expectations, right? And science is we don't know. But if you could, are there any expectations or predictions that you have in your work?
One of the things that my lab is focused on now is how to remotely monitor the well-being of patients with epilepsy. And this borrows from a large body of science in the wearable community, looking at how patterns of rest and movement and activity can encode symptoms of depression and anxiety and seizure exacerbations. And so my goal is, from my own research, that over time, we use some of these technologies to watch how patients are doing live in their own worlds, and have sort of a dashboard, if you will, and watch a community of patients over time and monitor not just their seizures, but also some of these other aspects of their syndrome that are equally disabling. And this is moving towards a field that is more data-driven, that's more digital. And so, in the old way, which is the current way, sadly, you meet your doctor every 3 or 6 months. He or she says, how have you been? How's your sleep? How's your mood? How many seizures have you had? And recalling that information is tricky. It's prone to bias, and it's not often very accurate. But what if you could collect that data every day, automatically and objectively? And what would you do with that data? How could you use it to predict the likelihood of symptom worsening? How could you integrate it into how we measure the success of our anti-seizure medication trials, and so on and so forth? So that's the type of scientific effect that I'd like my research to have moving over time. Now, obviously, just like humans have a circadian rhythm and have sleep that's interrupted by wakefulness, we can measure a lot of those same properties in mice and rats. And the advantage of studying these diseases in mice and rats is that you can study the illness without the confounds of the treatment, which is a luxury that we don't have in human subjects. By the way, in mice and rats, you can also study the treatment in the absence of the illness. You can take normal mice and rats and give them these drugs and ask, how does that change your mood? How does that change your movement patterns, wheel running, so on and so forth? And in a manner that's unrelated to whether you have seizures or not. So that's the long-term goal of our lab's work. I
have to say, I like that last bit you said, using rodents to measure the impact, say for instance, of drugs on people who don't have on residents that don't have epilepsy? Because sometimes I've found, and other people that I've spoken to, and no doubt with your patients, it's like sometimes we don't know how affected we are because our senses can feel so diminished, and you're so used to things like, I don't really know how I'm affected now. I just feel rubbish.
I like how you put that. Sort of this feeling of just blah, numbness. You're not excited about things. You're not upset by things. It's just almost a state of dullness, if you will. How can we measure that in humans? How can we measure that in mice? And, as I tell my patients, these drugs that we use, they don't just act on the parts of your brain that are causing seizures. They act on all of it. And so it's not surprising that many of these drugs are associated with changes in sleep, in mood, in memory and personality, rage. And the sad part is, if you look at, there's one study that I often quote where they looked at thousands of new medication trials, and they asked how many of them stayed on that new medicine and how many of them had to come off of it. Well, some drugs were better than others, but at the end of the day, the patients that had the highest likelihood of developing an intolerable side effect were the ones that had a history of psychiatric illness to begin with. So these two things are compounding each other in a way that's really terrible. If you have a history of psychiatric illness, you're more likely to have a side effect to a commonly prescribed anti-seizure medication. And if you have a history of psychiatric illness, you're more likely to have medically refractory seizures. And that means that you've got fewer and fewer medicines to work with, and there's a higher and higher likelihood of needing to have a surgical treatment. And I have nothing against surgical treatments. I advocated for it all the time. I'm involved in surgical treatment strategies here at Baylor. And I think that while some treatments like resection are permanent and irreversible and can lead to an irreversible deficit or a change in behavior, other treatments are not permanent. Like, for example, neuromodulation or neurostimulation, where you put an electrode in, but if you don't like how you're feeling with those set of stimulation parameters, you can stop it, turn it off, change it to something else, and learn from what works and what doesn't work. And clearly, the one message that you get from working with neurostimulation is that not every patient is the same. And so in the search for generalizable knowledge, which is research, using mouse or rats, can we really develop generalizable knowledge that's generalizable to all patients? I don't know. We'll see. That's the challenge.
We've spoken largely about seizures and depression and anxiety. Do you think there is a role for, or would you say there's a need for neuropsychiatrists and people who have relatively deep insight into both psychiatry and epileptology?
Of course, please. I wish I could have a psychiatrist with me during all of my visits, and we could sit together and think about the two sides of the coin. From a practical sense, I think that that's probably very difficult to institute in any medical system, whether it's national or not national. At the end of the day, it's important that one person is changing one drug at a time. And so if you have a psychiatrist who wants to change drug A, make sure the neurologist knows about it. There are some drugs that should be avoided by the psychiatrist because they can make seizures worse. And similarly, there are some anti-seizure medications that can impair mood, thought, and sleep. So this is the problem at the end of the day. So we need to be better integrated. We need to have a more collaborative environment to provide the comprehensive care that we claim to provide. Because if you look at most epilepsy clinics, in the United States at least, they're labeled the Comprehensive Epilepsy Center. But are they really that comprehensive, you wonder? Because they're, for the most part, mostly focused on seizure prevention.
And which is like, it's so silly and when you stand back from it, because if you're only looking at seizure prevention, you're not addressing other issues, it's say mental health or the stress that somebody, of whether they have autism or not, is experiencing, you're actually missing common seizure triggers. So it's silly.
Yeah, I think patients figure that out too. And I hope that there are more epileptologists in the future that are minded in this way.
A massive thanks to Vaishnav for sharing with us his knowledge of the intricacies of the epilepsies, of autism and or intellectual disability as well, and having his clinical work complement the scientific work and vice versa. If you've enjoyed this episode and would like to help us spread awareness and understanding of the epilepsies around the world, if you haven't already, please just do press the like and subscribe buttons. And see you next week.